divisor. But once there is a common divisor between the divisor and the moduli, your GCD is now, it will be greater than 1. And when that happens, you have to apply the theorem which can give you the value or solution to the question above. Now, if you look at this here, solution, step 1, check the GCD, check the GCD. Now, our GCD here for what? The divisor, which is 6, and the dividend, the moduli, which is what? 15. Now, there are parameters that we need to what? Itemized or named. Like now, A is equal to what? 6. That's our divisor. Now, 9 is, let's assume 9 is B, which is our dividend. Then, M is our 15, which is our moduli. Now, if you look at these two critically, aside 1 can divide 6 and 15, as well, if you check again, 3 can divide 6 and 3 can divide 15. So it means we have a GCD that is more than what? 1. It's not only 1 that is factor that can divide them. So under, we said 3. Now, the GCD is equal to what? 3. This implies that what? We are going to have 3 solutions to this particular single question. Now, what do? We have to employ the service of a theorem called CRT, which is what? Chinese remainder theorem. And what did that theory state? It states that CRT states that for division to be possible in modular arithmetics, the difference permit me to change to that side of the board. The difference between the divisor and the dividend must be multiple of the moduli. We can see it's saying for division to be possible in modular arithmetics, the difference between the divisor, what's our divisor here, is 6, and the dividend, what's our dividend here, we stated it here, 9. We say B equals to 9, must be a multiple of the moduli. What's the difference? 9 minus 6 is equal to what? The difference now is still a multiple of our moduli or not? It is, because 3 times 5 is what? 15. Therefore, it goes with this particular theorem. It abides by the rules of the theorem. Now, having stated that, using the definition, it says that is the difference between the divisor, this is A, which is our divisor, and the dividend, which is our B, is equal to multiple of the moduli. Moduli is M, the multiple is what? K. We can now say AX is equivalent to what? B plus MK. We know the meaning of A. We know the meaning of what? B. We know the meaning of MK. We know the meaning as it is stated here. Now, what do we check? We've known that our solutions are going to be what? 3 in number. Now, what do we do? We have A here is what? 6. 6x is equal. What is my B? 9. Plus what? What is my M? 15k. We divide through by the GCD. Here, 3 and 6 give you 2x is equal to what? 3 plus what do you have here? 5k. The multiple of what? Modular. Now, what do we do? The x, to know the numbers of what? The solution, we have to find this s. What do we do? After dividing this one, remember the new GCD, we now have what? New GCD to be what? Here is what? 3, then 5. We have 3 and 5. Now, what do we do now? Is equal to 1. You can see the GCD between 3 and 5 is equal to 1. Now, we have to now look for what? Inverse. That is what will help us to isolate this x. In normal algebra mathematics, to isolate this, I would have said 2x. You say divide both sides by 2. But in modular arithmetics, you don't do that. What you do is to take the multiplicative inverse of that particular unknown, which is x. And to get this multiplicative inverse, in this case, we have to look for a number that when we multiply with 2, it will give us 1 mod 5. Now, we have to check 2 times 1 is what? 2. 2 times 2 is what? 4. 2 times 5, that's 10. 5 in 10 is 0. 2 remainder 0. Now, we try 2 times 6. That is what? Oh, we've jumped a number. 2 times 3. 2 times 3 is what? 6. 5 in 6 is what? 1 remainder 1. That technically means that what? The multiplicative inverse of 2 is 3. Under modular 5. Multiplicative inverse of 2 under modular 5 here is 3. Therefore, we say what? Multiply through by 3. That means this 3 will cancel what? This particular 2. Pardon, please. Let me make use of the other side. Okay, when we multiply through by 3, we are going to have this particular 2 now. 2 inverse is what? 3. So this 3 is going to take this 2 away. We now have x. Now, 3 times 3 is what? 9. Remember, you are in modular. Okay, let me have it this way. 5 plus. Now, you are having 5k here. We change this k to multiple of what? T. So here, we say what? 3 times this 3 is 9. 5 in 3, that is 5 in 9, sorry. That is 1 remainder 4. So you have 4 here. Now, this 5k we change it to what? Multiple of what? 5t. Now, we have x equal to 4 plus 5t. Remember, our GCD from the question shows a value of 3, which means the solutions are 3 in number, and in modular arithmetic, you start counting from 0. So we have t at 0, 0.1, and 0.2. So we say at x equals to 0, at t equal to 0, s will be equal to what? 4 plus 5 times 0. You have what? 4 plus 0, which is what? 4. At t equal to what? 1, you have x equals to 4 plus 5. Now we have what? 4 plus 5, that's 9. At x equals to what? Equal to 2. At t equal to 2, x equals to 4 plus 5 into 2, we have what? 10 plus 4, 14. So x equals to what? 4, 9, 14. This is the solution to this single question. You can see 9 divided by 6 mod 15. The answer is giving you 4, 9, and 14. So this tells us that what? There's what? A huge gap or a very big difference between division of ordinary algebra and what? Algebraic processes that involve modular arithmetics. Don't forget to like the video, drop your comment in the comment section, follow our Facebook page, follow our YouTube channel, Amino Maths Class. We'll see in the next video. We'll solve more questions for us to understand this particular topic better. Thank you for watching, and bye-bye for now.